All right, the last part of the calculus homework is making sure you know how to do a few things on the calculator you should be able to do from before calculus. A third of the calculus test is calculator active, which means you're allowed to use a calculator. And there are a few things you should be able to do. The first thing is being able to find the zeros of a function or find the x-intercepts. Okay. I guess before we get started, if you don't have a calculator at home, if you have an Android phone, you can download the Wabbit Emu app. It will basically be a calculator on your phone. It's exactly the same as the calculators we use at school. You want to choose the TI-84 Silver is the closest one, although you can really use any of the calculators and it'll be fine. If you don't have an Android phone, but you have a computer at home, if you Google Wabbit Emu, you can also do it on a computer. You can basically have a computer version of the calculators we have at school. Okay, so let's look at how to do this. On the interval from 1 to 9, for what values of x does f of x equals 1/5 x plus 3 sin of x have zeros? Okay, so we want to find the zeros of this function. So all you need to do in a calculator, this is super easy to do, I need to change my battery soon apparently, is we clear out any functions that are there and we put in, we put in our function 1/5 x plus 3 sine of x. I'm going to make sure my mode is in radian mode. Always in calculus we will be in radian mode. In physics we use degrees, but in calculus we use radius. And I'm going to graph it. Now, there's a trick to speed up your calculator. I'm going to press Window and make the x resolution equal to 2. All right. So I'm looking for where the zeros are on the interval between 1 and 9. So the first thing you want to be able to do is set your window. If it gives you an interval, these are the x values. And so we're just going to choose the x values in our calculator that we want to see. We want the x minimum value to be 1 and the x maximum value to be 9. Min and max are the values. We also want to make sure the y min is less than 0 and the y min is more than 0. That way we can actually see where the function changes signs. And here it is. There's a point right here and a point right here. There are two ways to do this. The easiest way is to press second, Calc, this is where all the tools are, and we go to 0. It will ask you for a left bound. That means you're going to pick some value to the left of your 0. You see there's a little cursor on the screen here. We go to the left of our 0 and we press enter. And it asks for a right bound. You pick a point to the right of the 0 you're looking for and you press enter. And then you click guess and you just press enter one more time. And here it is. The 0 is at 3.368. So x equals 3.368. In calculus, we will always go to 3 decimal places. We'll talk about that more this year. There's a second 0 over here. So I'm going to press second Calc 0. My left bound is going to be to the left side of the 0. My right bound is to the right side of the 0. You just press left and right. I'm just pressing left and right on these cursor keys until it's to the right spot. Press enter and press enter again to guess. And the other x value is x equals 5.88. I don't need to put the 0 at the end because rounding to 3 decimal places there, you don't need to put a 0. Okay, so there it is. That's where it has zeros. All right, on the interval from -3 to 5, what are the x-intercepts of this function? Okay, well, x-intercepts are also zeros. So in your calculator, you would want to reset your window to go from -3 to 5, and we would want to know for this function. Put in this new function and find the zeros. F of x is defined on 1 to 9 in number 1. Where is f of x above 0? Well, this will be an interval, and since I already have this graphed, on the interval from 1 to 9, what intervals is f of x greater than 0? Well, to the left of this 0, the function was above 0, and to the right of this 0, the function is above 0, and so it's going to be on the interval from 1 to 3.368 union from 5.88 to 9. These are the x values where the function is above 0, from 1 until 3.368, and from 5.88 until 9. We know, even though we can't see the function here, we know it never came back down to below 0. It has to be above 0 because the function was didn't ever cross the x-axis. We usually use a closed interval when we're saying when something is positive or not, even though, we'll use we'll use an open interval. It's asking for where it's above 0, not for where it's greater than or equal to 0. So, let's see. B, intersections using them to solve equations. This is an example of an equation that it is not possible to solve. Let's say we decided we wanted to cancel out this e by doing natural log on both sides. We would get x equals natural log of x plus 2. And now we can't solve this part because there's still two x's. And it turns out when you mix a linear equation with an exponential equation, there is no analytic way to solve this. But if you have a calculator, it's very easy to do. All you do is you graph the left side. You graph e to the x in y1, and in y2, you graph x plus 2. And where they intersect, that's where these two will be equal to each other. I can't see here where they intersect, and so I'm going to make my window go from, instead of going from 1 to 9, I'll go from negative 10 to 10, and negative 10 to 10, just to start out with. And here I can see two intersections. Here's this exponential. It'll intersect with a linear right here and right here. The way we find it is we press second calc intersect, enter, enter, enter. And it'll tell us the intersection is at x equals 1.146 and y equals 3.146. The x value is the x value that makes both sides equal to each other. The y value is when x is 1.146, what both sides are equal to. We don't really care what both sides are equal to. We just care what are the solutions to this. And the solutions are what x values make the two sides the same. So the first solution is x is 1.146. Notice I went to 3 decimal places again. And the second solution, if I press second calc intersect, enter, enter, enter again, it'll just keep finding me the same solution. So when there's more than one intersection, we need to press enter, enter, and then before we press enter a third time, it says guess. We need to move our guess so that it's closer to this other intersection. And then we press enter. And it says the other intersection is at x equals negative 1.841. Okay. Similarly, we want to know on the interval from 0 to 2 pi, when does 2 cosine of x equals 1.5? This is something we actually could solve without using a calculator, but it's much easier to solve with a calculator. Again, we're just going to put 2 cosine of x on the left side and 1.5 on the right side and graph them. This time it tells us an interval. It wants to know where they're equal to. So I'm going to change my window to go from 0 to 2 pi. And so that makes the x values go between 0 and 2 pi. There's cosine of x, and here's 1.5. And again, you just have to press second calc intersect, enter, 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 and it jumps right to our intersection. And we can find the other intersection by pressing second calc intersect, enter, enter, and then moving our guess, moving the guess to the left until we get closer to this one. So those are the two intersections. So that's a cool thing. We can also use it to solve inequalities by finding the zeros or intersections and creating an interval where it's between those x values. So hopefully that's helpful. And you're feeling good about all your calculus homework. If you still have questions on any of your calculus stuff between August 6th and August 8th from 9 to 12 p.m. In my room, I'll be there to help you out. You really want to have everything done as much as possible. This is not the time to come learn how to do a whole bunch of stuff. It's the time to come get questions, to get some help on specific questions. Maybe you'll have a lot, maybe just a few, but you know, if you're waiting till the end of the summer to start your homework, this is going to go very, very badly for you. Good luck on the rest of your homework and have a good summer.